So I should have said something about this solution that we had in that last example. So we got 7 by following the normal, algorithm steps that you would use to solve radical equations. But when you plugged it in, it didn't satisfy the original equation. So they have a name for that, and I believe I'm spelling this right. All right, you could Google it, but this is called an extraneous solution. All right, and it is exactly what I said it is, but it's a solution that you obtain by following the normal procedures, but it doesn't satisfy the original equation. All right, so like if you plugged in 7, it wouldn't balance the equation. All right, that being said, let's move on and check for other extraneous solutions. So that's the reason that you have to actually plug in your answers for these. It's because stuff like that can happen. All right, normally if I was faced with this problem, I would start by multiplying by 3, clearing the denominator. But what I notice here is that if I go ahead and square both sides, this is going to give me a 4 over 9 x squared. All right, that's what I'm going to get if I square this. So 2/3 times 2/3 is that. And then if I square the right side, I'm also going to have a 4/9 x squared over there. So what I can do is I can just cancel those bad boys out. All right, so that one can cancel with that one. And so we're left with 0 over here. All right, what am I going to do next? Next, I'm going to go ahead and I'm going to plus the 4x to both sides. I'll add 4x there. I'll add 4x to the 0 over here. 4x, and that's going to give me 4x is equal to -2. Divided by 4, divide by 4. And so x is equal to -1/2, 2 over 4, -1/2. But now you would want to plug this in and see if it satisfies the equation. All right, so the left side would have to equal the right side. So let's go ahead and try this one with the calculator here. So -1/2, we'll store that to x. I'm going to focus on the right-hand side here. Square root of 4/9 and then x squared minus 4x minus 2. So I get 0.33333 repeating, which is 1/3 as a decimal, or 1/3 as a fraction. On the left side, if I do that one, 2/3 x, I get -0.33333. So this is not a valid solution. This is an extraneous solution again. All right, it was our only solution that we got whenever we followed the steps, but it doesn't satisfy the equation. So it's not an actual solution. All right, so this has no solution. So you could put that if you wanted to. You could say there's no solution for this thing. All right, no solution. All right, next up. So for this one, we need to isolate the radical part first. So I'm going to move my 4 over. That's going to give me square root of x squared minus 5x is equal to x minus 4. Next up, we're going to square both sides. Now when I square this side, it's not just x squared minus 16 or something like that. You got to square the whole darn thing like that. So the squared is going to kill that square, or square root. So you get x squared minus 5x, unlocks all that. For this one, what you're going to do is you're going to do x minus 4 times another x minus 4. This is going to be x squared. I'm going to go ahead and save a step and just, you do the double distributive property over there. This is what you're going to come out with because you got two 4x's. X squared can cancel with an x squared. Let's go ahead and move the negative 8x to the left side. So add 8x to both sides. That's going to give us a positive 3x is equal to a positive 16. So that means x will equal 16 over 3. Nice. Now I got to see if it works. All right, so 16 over 3. And we got to plug it into the original equation and make sure that it comes out nice. All right, so I'm going to do 16 over 3. Well, here. You could store it to x. I'll just I'll type it in without the store button. 4 plus square root. So this is going to be 16 over 3. 16 divided by 3 squared minus 5 parentheses 16 divided by 3. Okay, and I've got my square root thing all over that. I need to arrow over. And oh, that's it actually. There we go. So the left side gives me 5.33333. The right side is just x, which is 16 over 3. And they are a match. All right, you get the same thing back on the left as we did for the right, which was 5.33. All right, let's check out a tough one. All right, so on this one, again, I could divide by 3, but I'd end up getting like a 1/3 over here. That's going to be ugly. So let's go ahead and square both sides. There's nothing else on this left-hand side. So I'm going to square this. I'm going to square this. So 3 squared is going to be a 9. And then the rest of that part, the square root's going to cancel. Okay. We'll do 6x minus 1 times itself. So I get 36x squared. I'm going to get a negative 6x and a negative 6x, so negative 12x. And then a negative 1 and a negative 1 will make a positive 1. Okay, distribute the 9 real quick. 36x squared minus 3x minus 1. Same thing. All right, get rid of your 36x squareds because those are the same thing. What do we need to do from here? We need to move I'm going to move my 12x to this side. I'll do that. And we need to move this 1 to the right side. All right, so plus 1, plus 1. That's going to give me a 9x over here. Got it. Cancel, cancel. And then you get a 2 on that side. All right, 9x is equal to 2. Divide by 9. And you get 2 over 9 as your answer. Oh, man, hard part now. You got to plug it in and make sure it works for the equation. Okay, so 2 over 9. We'll store that to x. Okay, so we're going to get 3 square root. It's 4x squared minus 3x minus 1. All right, that's my left side. Ooh, that's a bad deal right there. Automatically a no-go. Automatically a no-go. So whenever I plugged in 2 over 9 for x, whenever I plugged it into the left side, I got an imaginary answer there. This is bad because we're not going to accept those in this world. Even if you typed it on the left side, it doesn't matter whether it satisfies it or not. We're not going to accept this as an answer. All right, because 2 over 9 is not in the domain of this function. All right, let me show you. Okay, so I was saying that 2 over 9, what happens is when you plug that into this function, it gives you an imaginary number. So 2 over 9 is not in the actual domain of this function. If I zoom out here, So what that means is that you can't plug in 2 over 9 into the function. Like, there's no x value. It's not defined for 2 over 9. 2 over 9 would be like 0.22222, so it would be right here, but it's not there. All right, and so 2 over 9 is not an actual solution. All right, so 2 over 9 is extraneous. It's a bad solution. So make sure you plug in those answers to check them. Okay.